6.5, confirmed. Sectors are all concurrent.
You sure about that?
I'm reading it right here, pal.
In the modern context, warfare takes place not only on the ground but also in the skies, where fierce aerial battles can determine the success or failure of an entire campaign. The rapid advancement of technology has made airstrikes one of the key factors that can change the course of war. To counter aerial threats, nations continuously invest in researching and developing advanced air defense systems to protect their forces and territories from enemy attacks. One of the most prominent and notable air defense systems from Russia is the Strela-10 missile system. The Strela-10 system is not just a simple air defense weapon, it also stands as a testament to the continuous advancement of Russian military technology. Since its introduction, the Strela-10 has quickly established its position on the battlefield thanks to its flexible operational capabilities, high accuracy, and impressive target elimination effectiveness. Designed to counter threats from helicopters and low-flying aircraft, the Strela-10 has demonstrated superior capabilities in various real combat situations. The inception of the Strela-10 is the result of years of research and development, with the aim of creating a mobile air defense system capable of protecting infantry and mechanized units from aerial attacks by enemy forces. This system is not only equipped with the most modern technologies, but is also continuously improved to meet the ever-increasing demands of the modern battlefield. The outstanding achievements and superior combat capabilities of the Strela-10 are not accidental. They are the result of the combination of advanced technology and flexible combat tactics, making the Strela-10 one of the most formidable air defense systems in the world. From its ability to detect and track targets to its rapid deployment and attack capabilities, the Strela-10 has proven itself to be an indispensable weapon in the air defense arsenal of many nations. Among the notable air defense systems, the Russian Strela-10 missile system is considered one of the most effective weapons in destroying low-altitude aerial targets. So what makes the Strela-10 so powerful on the battlefield? What factors have turned it into a crucial tool for protecting the skies against enemy Air Force invasions? Next, we will delve into analyzing and evaluating the Strela-10 system in detail, from its development history and technical characteristics to its actual effectiveness in military conflicts. Through this, we will gain a clearer understanding of the role and importance of the Strela-10 in maintaining air safety and sovereignty for modern armed forces. Develop. The 9K-35 Strela-10 is a highly mobile, low-altitude surface-to-air missile system guided by infrared/optical control. The 9K-35 is the successor to the 9K-31 Strela-1 and can also utilize Strela-1 missiles as substitutes for the 9M-37. The development of the 9K-37 Strela-10 SV system began on July 24, 1969. The decision to develop a weapon that does not operate in all weather conditions was made despite the simultaneous development of the all-weather gun/missile system 9K-22 Tunguska, mainly for economic reasons. It was also considered advantageous due to its quick response time and immunity to electronic frequency jamming. Instead of being mounted on a light amphibious armored vehicle like the BRDM as with the SA-9, the SA-13 was mounted on a more mobile converted MTLB vehicle, providing more space for equipment and reserve missiles. The Strela-10 SV system and its 9M-37 missiles were tested at Dongascom between 1973 and 1974, but the results were disappointing. The system was found to be ineffective in target elimination, vehicle reliability, and other issues. As a result, acceptance into service was delayed until May 16, 1976, by which time several improvements had been integrated into the system. The development of the system continued over the years, leading to the introduction of variant Strela-10M, -10M2, and -10 cubic meters, along with numerous other enhancements, including radio communication improvements and better integration with the Soviet air defense data imaging system. Similarly, new missiles were developed, and in September 2007, the 9K-35 M3K Kolchin variant, mounted on a BTR-60 wheeled vehicle, was first showcased at the Moscow Air Show MAKS 2007. Parameters and formation process. The 9K-35 Strela-10 is a Soviet low-altitude surface-to-air missile system, produced from 1973 and inducted into the military in 1976. The Strela-10 weighs 12.1 tons, has a length of 6.45 meters, a width of 2.85 meters, and a height of 2.22 meters. Using the MTLB multipurpose armored vehicle chassis, it boasts high mobility. The system is powered by a UMZ-238V diesel engine, with a power output of 240 horsepower, enabling it to travel at a speed of 60 km per hour and providing a range of 500 kilometers. The primary weapon of this system is the 9M37 missile, guided by infrared/optical systems. Each missile is 2.2 meters long, with a diameter of 0.12 meters, and weighs 40 kilograms, including a 3.5 kilograms warhead. The missile can reach a maximum speed of Mach 2, has a ceiling of 3,500 meters, and an operational range of 5,000 meters. The Strela-10 carries 4 missiles in launch-ready tubes and has 8 additional missiles stored inside the vehicle for reloading, a process that takes only 3 minutes. The MTLB chassis has a higher load capacity than the BRDM, allowing it to carry up to 8 intercept missiles inside and 4 ready-to-launch missiles. The Strela-10 variant can receive data from an air defense command center or a nearby radar station, increasing the likelihood of destroying a target with a single missile to 30 to 60%. It is equipped with flotation devices for swimming at speeds of 5 to 6 km per hour. Additionally, the Strela-10 is armed with a 7.62 mm machine gun, carrying 2,000 rounds, with a firing rate of 800 rounds per minute and an effective range of 1,500 meters. The standard equipment of the system includes an advanced thermal imaging sight capable of observing targets in fog and behind clouds, the 9S-86 snapshot target classification radar mounted between 2 pairs of missile containers, and the teleradar with a maximum operational range of 10,000 meters. Recently, leaked images show that this air defense system has been additionally equipped with an infrared camera to detect, track, and target aerial threats. The addition of the infrared camera is believed to enhance the system's ability to detect and effectively destroy targets, especially unmanned aerial vehicles in nighttime conditions. The Strela-10 air defense system, developed and produced by the Soviet Union in the 1970s, despite its age, remains capable of eliminating UAVs in modern combat. Since its inception, the system has been continuously upgraded, with the most common variant today being the Strela-10, which can differentiate between actual targets and infrared decoys. A significant difference between the Strela-10 and the Strela-1 is that the former initially used the BRDM wield armored reconnaissance vehicle chassis, while the latter uses the tracked MTLB vehicle chassis. The latest variant, the Strela-10M, continues to improve its fire control system to intercept UAVs and cruise missiles. This variant incorporates the 9M333 interceptor missile, weighing 42 kilograms with a 5 kilograms warhead. The 9M333 missile operates on the fire and forget principle, meaning it autonomously seeks and destroys the designated target. It has 3 operating modes for the seeker head: electro-optical, infrared, and anti-jamming. Due to the integration of the hatbox targeting radar on the vehicle, the system maintains high mobility. The use of new components with improved characteristics necessitated an increase in missile length to 2.23 meters, while the diameter remains 120 millimeters, and the weight increased to 41 kilograms. The probability of hitting the target has also been increased by enlarging the explosive area and the length and cross-sectional area of the attacking elements. The missile is equipped with a passive infrared seeker combined with a proximity laser fuse. Military UAVs, despite their slow flying speed, are challenging to intercept due to their small size and low flight altitude. Recent conflicts have demonstrated the effectiveness of the Soviet-era air defense system. The combat history of the Strela-10 includes notable achievements such as Angola using it to shoot down a South African Mirage F-1 in 1988, during Operation Desert Storm in 1991, 2 U.S. A-10 aircraft were downed by Iraqi missiles. The Strela-10 was also used by eastern Ukraine separatists to down a government and 30 reconnaissance plane in 2014. In 2021, A Strela-10 air defense system with 9 M37 missiles successfully shot down a Chinese-made CH-4 reconnaissance armed drone serving the Royal Saudi Army. Strela-10 destroys F-18. An F-18 accidentally flew over the air defense site of Yugoslavia. The ground-based air defense forces launched a 9 M37MD missile from the Strela-10 mobile air defense system. The F-18's warning system quickly sounded an alarm, and the pilot immediately increased altitude to evade the first attack. However, the 9 M37MD missile continued to pursue the target. The F-18 pilot deployed heat decoys, consisting of multiple flares, to create false infrared signals mimicking the aircraft's engine. Yet, this tactic did not fool the missile. Seeing that the first missile might not hit the target, the Air Defense Forces launched a second 9 M37MD missile. The pursuit of the two missiles forced the American pilot to jettison the external fuel tanks, both to reduce the aircraft's weight and to increase maneuverability for the escape mission. Additionally, the fuel tanks exploded upon hitting the ground, creating a large fireball that temporarily obscured the target. One missile was unable to maneuver in time and exploded as it passed through the fireball. Nevertheless, the remaining missile persisted in its chase despite the F-18's climbing and sharp maneuvers. Even though flying in the opposite direction, the 9 M37MD missile managed to turn back and continue tracking the aircraft. It got close enough to the target and detonated, causing the F-18 to burst into flames. The pilot and co-pilot ejected safely, parachuting away from the burning aircraft. Although this is a staged scenario, the events help readers understand the operation and strength of the Strela-10, a mobile air defense system within the Vietnamese Army's air defense forces. Readers can also gain insight into air defense tactics and the countermeasures employed by modern fighters. The Strela-10 is a short-range air defense missile system with a combat range of 5 kilometers. The system's missile uses an infrared homing seeker, achieving flight speeds of up to 550 meters per second. In reality, the Strela-10 has demonstrated combat capabilities in the battlefields of Iraq and Yugoslavia. According to some statistics, the Strela-10 has shot down at least 2 American aircraft in Iraq and damaged 2 others in Yugoslavia. Development potential. Overall, such combat usage results are not surprising. The Strela-10 series systems have several important features that ensure high efficiency in the fight against aerial targets. All major modifications of the Strela-10 air defense system are built on the MTLB chassis. This vehicle type has sufficient load capacity and high maneuverability, and it is widely used in the military, making it well managed in terms of operation. The air defense system on the MTLB chassis can accompany troops on marches, including tanks, over rough terrain and provide continuous defense capabilities. The Strela-10 operator searches for targets and conducts preliminary guidance visually or using optical observation devices / electro-optical stations. Radar is only used to estimate the target's position and missile launch capability. It can also work with external target designation. All this ensures sufficient accuracy and speed while reducing radiation from the combat vehicle, making it harder for the enemy to detect. All missiles in the Strela-10 air defense system family have similar structures, but in later products, thanks to new element bases and other solutions, they can fully exploit their existing potential. The latest projectile of the Strela-10 is the 9 M333 guided air defense missile. It was first showcased in 2020, and later information indicated that the tests were successful and deliveries to the military had begun. The 9 M333 is a solid fuel-guided missile, over 2.2 meters long, with a body diameter of 120 millimeters and a weight of 41 kilograms. The high-explosive fragmentation warhead weighs 5 kilograms, significantly heavier than previous missiles. An advanced infrared seeker is used. The launch range is up to 5 kilometers. During the special operation, later versions of the Strela-10 system demonstrated the ability to timely detect aerial targets of various classes, including the most complex ones, such as small UAVs. Thanks to modern high-performance seekers, the existing missile successfully tracked and ensured the destruction of such targets. It turned out that these seekers could confidently target even low-power UAV engines with limited heat generation and small-size visually contrasting objects. With all the advantages of modern modernization projects, the design potential is almost exhausted. Accordingly, the issue of further development of military air defense and re-equipment of units needs to be addressed. As the successor to the existing Strela-10 system, a new air defense system with the code name Sosna is being developed. So far, prototypes of such equipment have been tested, and the air defense system has received a recommendation for adoption. The issues of mass production and the start of equipment deliveries to the military are currently being resolved. In the long term, the new Sosna systems will need to complement and then replace the existing Strela-10 systems. Such a replacement will only have positive consequences. The Sosna air defense system is created based on the experience of operating and using the Strela-10, thus featuring several important differences and features. Thanks to these, all basic technical, operational, and combat characteristics are achieved. Sosna is proposed to be built on modern common chassis of our military. For ground forces, an option based on the BMP-3 has been proposed, while airborne forces will use the air defense system on the BMD-4M chassis. This complex includes an improved electro-optical detection and observation station. Like its predecessor, Sosna practically emits nothing during operation. A completely new missile, the 9M340, has been developed. In design, it is similar to the 9M333 but has a completely different guidance system. Instead of ICGSN, it uses a beam-riding laser guidance system. The vehicle's equipment is responsible for guiding the missile, achieving high accuracy and noise resistance. The launch range is said to be 10 kilometers, with an altitude of 5 kilometers, far exceeding the parameters of the older missile. Thus, in the special operation to protect Donbass, the Russian military faced active opposition from enemy drones. However, it turns out our military has a fully modern and effective means to counter that threat, the later versions of the Strela-10 air defense system. Additionally, fire suppression systems, other firefighting equipment, etc., have been put into use or newly introduced. In response to the persistent existence of major threats, a decision was made to expand the presence of such air defense systems in the military and improve their air defense capabilities. This will be achieved by forming new units that will deploy the Strela-10. At the same time, there is the basic potential for further upgrading such units. A next-generation ground-based air defense system with enhanced characteristics has been created and tested. Thank you for watching the entire video. If you found this video helpful, don't forget to like, share, and subscribe to support us. See you in the next video.